So we're on 2A.3 absolute value functions. And we're going to start off with the first part. So talking about key attributes of the function. So our key attributes that we're going to look at are for our absolute value function. Do we all remember the absolute value function from Algebra 1? It was the V-shaped function. Is that ringing any bells? Okay, well, this is your absolute value function, and this is its parent function. The parent function is where everything starts and comes from, right? So our parent function here is f of x equals the absolute value of x, okay? Your absolute value is saying that your x has to always be positive. The output's going to be positive of the absolute value, okay? So if you look at it, it's primary values that we analyze. When I input a -3, my output is a +3. That's because absolute value is describing distance. How far is a number from the origin, right? And distance, is distance negative? No. If I walk backwards, I'm not going to say I just walked a -mile. No, I'm just a fool who walked backwards for a mile, okay? My distance is still just 1 mile, all right? Now we're going to talk about important attributes of the absolute value function. First, we have its vertex. Your vertex is going to is your lowest or your highest point of your absolute value. So it's either the peak or the valley of the V, right? So it's either going to be a max or a min, okay? After that, we have our axis of symmetry. Your axis of symmetry is the invisible line that divides your absolute value into two parts. Those two parts are a negative slope and a positive slope. A line with a negative slope and a line with a positive slope, okay? Your domain, because your function goes forever to the left and forever to the right, is all real numbers, which means that it goes from negative infinity all the way to positive infinity. Your range is based off of your low to high. In this case, it's going to be our low. Our minimum value is at 0. So our function starts at 0 and continues to infinity. And then last but not least are your intercepts. Your intercepts are where do you cross the x and y axis? When does x equal 0? When does y equal 0? And in this case, it's at the origin. Okay, so that's our parent function attributes. And now we're going to graph some functions and analyze them, okay? You are the calculator. You are the graphing calculator, and we're going to go over the ways to graph absolute value functions. So up first, we have option A. Option A is when you have a absolute value written in the form of a absolute value of x minus h plus k. It tells us everything you need to know about the graph in order to graph it. What we're going to do is the table method right now. We're going to create a table of at least 3 values. One value should be your HK, your vertex. So HK is your vertex. Now, key thing to remember here is that your H looks like a negative, but it's really not. It's actually a positive because the function in standard form is x minus h. So this is a positive h, not a negative h. The way I like to remember that is that x's are liars. That's why they're x's. Okay. X's are liars. So when I look at this, I'm not like, oh, it's negative, blah, 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 blah. Oh, no, it's a positive because my X is a liar and it's trying to confuse me. Okay. All right. Choose 2 to 3 X values to the right and left of the vertex. You're going to substitute those values in and evaluate to find Y. Okay. You evaluate. All you're doing is going through the order of PEMDAS. Okay. Absolute values count as part of the P of PEMDAS. Because you got to do the inside first. All right. And then you're going to plot the points in the graph and connect them. How do you connect them? You connect them by identifying your slope and using your slope to connect your points. After that, here's the easy part. What's my domain? What's my range? What's my axis of symmetry? And what are my intercepts? Does that sound doable? Yeah? All right. Are we ready to try? Okay. So up first, we have example A, and it says f of x equals the absolute value of x plus 2 minus 3. So absolute value of x plus 2 minus 3, we're going to first start by identifying our vertex. for this problem, what is our vertex? What's our H and our K? So we have H and we have K. Remember, our X is a liar. It looks like it's positive, but it's actually a -2. So our vertex is at -2 and -3. So that's going to be the center of our table, -2, because that's where our vertex is. And its output is -3. Okay. The next step says to choose points to the left and to the right. So points to the left of -2 would be -3 and -4. Points to the right of -2 would be -1 and 0. I'm not going to choose big points. I'm going to choose small values so that I can easily do the math and keep it pushing. If your heart tells you to do -100, go for it. No one's going to stop you. I'm just going to tell you it's pointless. And our graph does not go up to -100. Okay. All right. So, now we are going to plug in. So we have -3. I'm going to substitute -3 plus 2 minus 3. We have -4 plus 2 minus 3. We have -1 plus 2 minus 3. And we have 0 plus 2 minus 3. Okay, when you're evaluating, be mindful. The absolute value job is to do what? Get rid of what? Negatives, because it's asking you what is the distance to the origin. Okay, so -4 plus 2 is -2. But what is the absolute value of -2? 2. So it becomes 2 minus 3. And what is 2 minus 3? -1. Okay, -3 plus 2. -1. What is the absolute value of -1? 1. What is 1 minus 3? -2. What is -1 plus 2? 1. And what's 1 minus 3? -2. What is 0 plus 2? And 2 minus 3 is -1. Was that terrible? Oh, it was so horrible. I know. All right. So we're at -4, -1. We're at -3, -2. We're at -2, -3. We're at -1, -2, and 0, -1. It said that when we connect the points, we want to use the slope to help us find the remaining points. So on my right side, my slope is I rise 1, go right 1, right? So 1/1. So I'm going to 1/1, up 1, right 1, up 1, right 1, up 1, right 1, up 1, right 1, up 1, right 1. My right side is done. And we're going to pretend that your teacher went through all of the points, per usual. Straightest line you've ever seen. Okay, on the left side, my slope is up 1, left 1, up 1, left 1, up 1, left 1. Connect. And bam, we did it. Okay, now we're going to find our domain and our range. So the domain of this absolute value function is what? Does it stop? Does it go forever left, forever right? Yes. All real numbers. So from -infinity to positive infinity. It goes forever. Even though I don't see it going forever, there's no defined ending point to this function. Your range. Well, my range, I got to decide. Do I have a max or a min? A min. So what is my lowest point for this graph? -3. So we know that y is greater than or equal to -3. Or we can write it from -3 to infinity. Your axis of symmetry is the invisible line that divides this function into 2 equal parts. What is that invisible line at? X equals -2. Questions about identifying domain, range, and axis of symmetry. Okay, last is our intercepts. Our intercepts are where do we cross the X and Y axis? Where do I cross the X and Y axis? At -5. Where else? I cross at 0, -1. And where else? And at 1, 0. So these are my intercepts. I'm gonna squeeze it in there. That says intercepts, I promise. It's just getting worse. Okay, how do we feel? Did we survive? Barely. I'll take it. Go crazy. All right, next. I'm going to give a fraction example because a lot of times when we see fractions, we freak out like, oh, Jones, oh, made it harder. Oh, fractions are our friends, you big crybabies. Okay. We're going to do the exact same thing that we did. All right. So step 1 is to identify your vertex. What is the vertex? Where's your H and your K? It's gonna be 1, 0. My H is 1, and there is no number here, so it's 0, the friendly ghost. X's are liars, so our vertex is at 1, 0. We have 1 and we have 0. And that is our vertex. Okay. Now, this is the tricky part with fractions. To avoid having unnecessary fractions, you want to choose friendly numbers that would plug in and work with the fraction. So if I have a fraction of 1/3, that means I'm dividing whatever set number by 3, right? So I want to think of what would make the inside of my function equal to a multiple of 3. So 3, 6, 9, 12, 15, any of those numbers so that it's easier for me to work it. Okay. So for example, I have X minus 1, right? If I want X minus 1 to equal 3, what would this have to be? It would have to be 4. So a good number to use is 4. Does that make sense? Okay. Still with me? All right, perfect. If I let, where we at? What about if I wanted it to be -3? What would I need to let it be? It would need to be? It would need to be a -2. Why would it need to be -2? Exactly. A negative plus a negative is a negative. So it would be a -2. Now, we could choose more numbers, but will those numbers fit on our paper? No, it won't, because our graph only goes from -5 to 5. We could do -5, though. It'll work. Why can I do -5? What's -5 minus 1? -6, right? All right. So we're going to plug in what we have. So when I plug in, so I have 1/3, -5 minus 1, that equals 1/3 times 6. Is that class real? All right, that's going to give us 2. I'm going to plug in 1/3 absolute value, -2 minus 1. That's going to give us 1/3 times 3, which equals 1. I'm going to have 1/3 absolute value of 4 minus 1. That's going to equal 1/3 times 3. That's going to give us a 1. If I plugged in the next one, it would be 7, right? That's because 7 minus 1 is 6, and 1/3 times 6 is 2. So that's how you work with fractions. You find numbers that are going to be nice to divide with. Does that make sense? Gosh, look at you making a connection. Okay. So now when I graph, I have -5, 2. We have -2, 1. We have 1, 0. We have 4, 1. So our graph is looking like, it's a pretty wide vertex. All points are connected. So again, your domain is still from negative infinity to positive infinity. Your range now starts at 0. Y is greater than or equal to 0. So we're from 0 to infinity. Our axis of symmetry is going to be at x equals 1. And our intercepts, we only have a x-intercept that we can clearly see. So we are at 1, 0, but there is a y-intercept. In order for us to find that y-intercept, we're going to find the value of 0. So if we set this equal to 0, what do we get? So we have 1/3 absolute value of x minus 1 equal to 0. That's going to give us x minus 1 equals, we're going to multiply by 3 to cancel out the 1/3. Going to make 0. And then we're going to add 1. I know I got 1. It should be 1/3. And we get x equals what? Oh, I did that backwards, guys. I was like, I'm tripping. I was tripping. We're just plugging in. I was like, we already knew that. Silly me. Ignore that. You saw nothing. We're plugging in 0 for x. 1/3 absolute value of 0 minus 1 because we want x to equal 0 and to find the y. So what is our y? Well, our y would then equal 1/3. So therefore our y-intercept is at 0, 1/3. All right, and that concludes the first part. Now we'll do option B in the next video.